6.4 is our last section of material, and it's the last section that we look at in Chapter 6 about differential equations as well. And this section is talking about linear differential equations, specifically first-order linear differential equations. And we're going to start with a definition. So a first-order linear differential equation is one of the form dy dx plus some function in terms of x times y equals another function in terms of x. So as you can see, that's awfully specific. Not everything would have this sort of very distinct form. And we have the feature that p and q are continuous functions of x, and this is the standard form for a first-order linear differential equation. You should use that word at lunch today. Somebody will look at you like you're very, very smart. That phrase, first-order linear differential equation. All right, so as is sometimes the case, we're going to do this particular section with kind of a list of steps of how to think about the particular problems. So the first thing we're going to do when we solve a first-order linear differential equation is we're going to put it into that standard form. So we want it in terms just like you saw on this previous one. We want it to say dy dx plus p of x times y equals q of x. We want it in that form. That's the first thing we're going to do. The second thing we're going to do is we're going to identify what p of x is. Well, it should be pretty easy to identify if we get it into this form, right? It's going to be the thing multiplied by y. Okay, so step 2 is just looking at the original step 1 and saying, haha, I noticed what's multiplied by y, and it's this value. Okay? And then we integrate it, and that may or may not be simple. It depends on the problem, right? So we're doing a little bit of integration. After we integrate it, we're going to let this other function u be u of x equals e to the integral of p of x dx. Well, that integral of p of x, that piece right there, that's what we found in step 2. So what we're really doing in step 3 is we're saying e raised to what we found in step 2. This value is the step 2 value. That's all it is. Once we find that u of x value, then we can do step 4. Now take a look at step 4. Step 4 sort of looks like you're doing something weird. Why? What looks weird about step 4 to you? Because to me, it almost looks like all I'm doing is integrating q of x. Do you see that? I mean, I've got u of x inside, and I've got 1 over u of x outside. So it almost feels like I should be able to just cancel those out. That's incorrect. It doesn't work like that. But that's what it looks like you're almost doing. It almost looks like you're multiplying by a q of x in one location and dividing by a u of x in one location and dividing by a u of x in the other location. Okay? So we've got this 1 over u of x on the outside that is not a part of the integral. That's the difference. Whereas the u of x on the inside, next to the q of x, is actually part of the integration. Do you guys see the difference? Okay. We're going to take a stab at trying one of these. And the first one we try is a pretty clean and simple one. We've got y prime minus y equals 16. All right, so the first step, step 1, is that we're supposed to get it written in this form. Dy over dx plus p of x times y equals q of x. This is the form we're looking for in step 1. Now, believe it or not, it's almost already in that form, right? So we're going to do a little bit of a rewrite, but this is dy over dx times minus 1 times y equals 16. That's step 1, is simply identifying it and writing it in the proper form. And on this one, it was almost there already. Step 2 is identifying what p of x are and what p of x is and what q of x is. So what is p of x in this problem? -1. How friendly was that? And what is q of x? 16. The other part, if you will, the part B of step 2, is to take this p of x and integrate it, right? So what is the integral of p of x? That is, what is the integral of -1 dx? It's negative x. This is not a difficult step on this one, right? Because the p of x value is very clean and simple. Step 3 is taking e and raising it to that power. Hang on, let me write it in the form that they do. This is going to be identified as u of x. It's taking that e and it's raising it to the value that I got in step 2. So u of x is actually e to the negative x. So far, so good? All right. Step 4 then is to write out y equals. It's supposed to be 1 over the u of x that we got in step 3. So this would be 1 over e to the negative x times the integral of q of x, which is 16, times u of x, which is e to the negative x dx. So looking at your paper, does that look like what we had written down at step 4 is supposed to look like now? Look okay? All right, so we'll deal with that 1 over business in a minute. Let's just rewrite it for now. What is the antiderivative of e to the negative x? Well, the 16 we get for free, but what is the antiderivative of e to the negative x? Right, so it'll be negative, so I'm going to put the negative in front of my 16, but it stays the same as e to the negative x, right? Oh, I'm sorry. Getting carried away copying. But there's something missing. What's missing right now? Plus c, and as you've seen before, anytime we seem to have these e's and stuff involved, I tend to put a C1 right there. Call it C1, call it C. It doesn't really matter what you're dealing with. It's going to have a C in the end. I think we're going to use, if we use C, I think it'll actually be okay on this one. But all right, so what do you see? What's next?
Can you flip that e to the negative x up to make e to the x?
You can. I'm going to leave it like it is for just a minute, Parker, but we're going to flip it after that. Okay? The reason I'm going to leave it like it is because when I actually distribute this, it's kind of nicer to see it written like that for the first piece. What is 1 over e to the negative x times negative 16 e to the negative x? That's just negative 16. But just like Parker said, e to the negative x in the denominator would be equivalent to what? E to the x, right by itself, yeah? So as I distribute it to the second piece, it's helpful to think of it that way because it's more concise, it's cleaner. So this problem ends up looking like negative 16 plus c e to the x. And that is the solution for the differential equation. So in other words, if I were to take the derivative of what I just squared in, I would be back, I could, after some manipulation, be back to where I started with y prime minus y equals 16. Okay? It's not so bad, right? Okay, I mean, we had a pretty clean one to start with. That p of x and that q of x were awfully friendly. But the process itself works the same way no matter how the problem looks. Now, the downside is that the next page that you have has one problem on it and a lot of space, doesn't it? Okay, so let's see what happens on this one. First issue is we're supposed to get it into the right form, yeah? So the form that we're supposed to get it into, let me remind you, looks like this over here on the top left. I'm going to copy it and put it over here as a reminder to us. This is our first goal, is to get it to look like that. It does not look like that right now, like at all. Agreed? All right, so what are we going to have to do to get it to look like that? That sounds like a good first step. Okay, so like that. Now what?
Divide by dx.
You guys are on a roll. You betcha. Okay, so now I have 1 plus y, or y plus 1, times cosine of x equals dy dx. Okay, now what? Yeah, we could do that. So I can have y cosine x plus cosine of x equals dy dx. We're getting close. Now what? This piece right here needs to be on the side with the dx, the dy dx. So I'm going to do that, and I'm going to write it on the left at the same time. So this is dy dx minus cosine of x times y equals cosine of x. Okay, so I rewrote it and I flipped it at the same time. Is everybody good with that? Okay. Notice I also wrote it with the cosine of x in parentheses and the y outside of that. I don't want you to think that if I write the cosine x before the y that somehow the x and the y then get multiplied, because they don't. But the y is written as the second value up here in the formula, right? So I want it to be written in that form to be able to identify everything most easily. That's step one. It is now written in the right form. Step two is to identify something. What is p of x? It's negative cosine x, actually, yeah. And what is q of x? Well, goodness, it's also cosine x, isn't it? All right. What else am I supposed to do then inside of step two? Yeah, I'm supposed to integrate p of x. So I need to integrate the negative cosine of x dx. So what is the integral of negative cosine of x dx? It is. It's negative sine of x. Okay, is everybody good with that? I think I have space for step 3 right here, because step 3 is a very short step. Step 3 is simply identifying what u of x is going to be. And u of x is going to be what? All right, good. E to the negative sine x. All right, everybody good through step 3? Typically speaking, steps 1 through 3 go fairly quickly. Step 1 might take a while. It did on this one. But steps 2 and 3 go pretty quick. Step 4, not so quick. All right, step 4 means that I'm going to take y equals 1 over the u of x. So u of x was e to the negative sine x. And just like in the situation on the last one where Parker noticed that we could flip that, this can be flipped, and we will eventually do that, okay? Because I've got a negative sine x in the denominator as an exponent and so forth. And I'm going to do the integral of q of x. So what was q of x? Good, cosine of x. Times u of x. Well, u of x was that e to the negative sine of x. dx. Do you like that integral? Jordan says he does. Jordan, what do you notice about that one?
You can make the u negative sign.
Right. That exponent is a wonderful thing to let u be. We want the whole thing, too, so negative sine x. So what would du be then?
Negative cosine.
Yes, it would. And we almost have that, don't we? All we don't have is the negative. Alrighty, so I think we're ready to work with this. This is still 1 over e to the negative sine x. I'm going to leave it like that for a little bit longer. So this is an integral of negative e to the x dx, I think, isn't it? Well, we used u. I guess I should probably stick with the right variable because I made a u substitution. How about that? Is that better? I think that'll do it for us. What is the antiderivative then of negative u e to the u? What is it, Stephanie? Yeah, it's the same thing. And we're going to have a plus c here, so let me go ahead and put it in for now. We may want to change how it's written in a minute, I'm not sure, but this is written in terms of u, and we don't want it written in terms of u. We want it written in terms of x, so this is negative e to the negative sine of x plus c, right? And then this starts to feel just like the last problem, doesn't it? I mean, it almost feels like the ending is identical, even though we had quite a bit of different things in the middle there, including some trig. So as I distribute this, what does the first piece become? -1. The second piece I can rewrite, recognizing that 1 over e to the negative sine x is actually the same as what? E to the positive sine of x times a c. So that would be fine to have it written that way. I'm going to write it with the c in the front instead, but you certainly could have left it. And then our problem solved. Okay, second one should have felt easier than the first because you've already went through all those steps and it was really the same towards the end, right? Very, very similar. Okay. Do you know what this last one is right here, number 2? Example number 2? It's the very last problem of the semester, isn't it, Chelsea? Yes, it is. Oh my goodness, look what we got here. We got cosines and secants and tangents. Oh my goodness. And it also says something about a particular solution. I mean, like, we didn't do that yet. But you've done it before. What does it mean to find a particular solution?
Find out what C.
It means find out what C is. And we have the information, the additional information to do that because we're told that y of 0 equals 1. So we'll be able to figure out what C is at the end. But everything up to the point of that is going to be just like the problems we've been working. Except that it looks like we've got some trig in here that we might have to actually think about a little bit because it's not sines and cosines. Not all sines and cosines anyway, right? All right, so step 1, step 2, step 3, step 4, they're all the same as they were before. Step 1 is to rewrite it in a certain form. I don't even think you probably need to see that form again. I think you know it. So what's my first step? Right, it's already in the right location, isn't it? dy dx plus, tangent of x times the y. Again, I'm going to write it kind of like I did the last time just to kind of clarify to us what we have there. And it equals secant x plus cosine x. And to be honest, that's your form. I mean, it may not be especially nice looking, but that's the form that you're asked to put it in for step 1. So you're done with step 1. All right, so what are we supposed to do in step 2? Right, identify p of x and q of x. All right, so what is p of x? Yep, tangent x. And q of x? Good. Okay. What's the other part of step 2? Right, integrate p of x. So I need to integrate the tangent of x dx. That's one of those you're going to go back and memorize for the closed note portion of your final. But if you don't have it on the tip of your mind right now, you can look it up. What's the integral of tangent of x? That's the derivative.
Natural log.
Ah, there we go. It's actually the negative natural log of the cosine of x. Yeah. So as you go back and look at those, keep in mind derivative versus antiderivative, because a lot of you are having trouble on the antiderivative basic skills quiz at writing down derivatives when you're supposed to do antiderivatives on some of those. All right, so this is negative natural log cosine x. There's another way to write that. Some of you actually encountered that. The other way to write this, as you used some internet resources, I think is where you saw it. But let me show you where it comes from, because I don't think you have a clue where it came from. The negative in front of the natural log is going to pose a problem for us eventually, because we need to do e to a power, right? And I don't want the negative in front of the natural log, because then the e and the natural log are not inverses directly. Does everybody follow me? I need that negative to be moved. So we've seen this in the problem, I think it was in the last section, where we said we could write this then as a -1 power. I think, Taylor, you're the one who noticed that, right? So what is that going to do to this right here? What is the natural log of cosine to the -1? That's the natural log of secant, because the reciprocal of cosine, or 1 over cosine, is equivalent to secant. So some resources will actually identify that as the antiderivative of tangent. Your book doesn't use that, which is why I haven't. But it certainly correct. I mean, there's nothing wrong with that. The antiderivative of tangent could also be written as the natural log of secant. That's the one that's going to be helpful for us because in step 3, we need to say that u of x is equal to e to the tangent value, or the integral of the tangent value, which is this natural log value. And notice what happens when I have e to the natural log of secant x here. That's just secant. So I'm actually not going to have any e to the x's in this problem as I work it because it cleaned itself up really quickly. You thought taking that antiderivative tangent was unfriendly, but it's actually quite friendly in this particular problem, wasn't it? It really was. All right, so this is my third step. Step 4. So step 4 is that y equals what? 1 over secant, otherwise known as cosine. We'll come back to that in a second, but it is. Times the integral of what? The q of x, which we identified earlier, which was secant of x plus cosine of x. All right. Times. Well, this one's just times secant x. It's times u of x on the inside. U of x is what's on the inside. So this is secant x and then dx. All right, so let's clean things up as we go. So I said already that outside's really just cosine, right? What happens inside? We can distribute. And if we do, we get secant squared of x plus, and what is secant x cosine x? It's 1, because those are reciprocals, right? That's good news. All right, then. So, do you see something? Identity, right? I almost wanted to break out into a song. Do you see what I see? It was the right time of the year for that, even. What is that identity? What is secant squared plus 1? Oh, my goodness. Have we not already seen this used today? Yeah. All right, so we've got an integral of tangent now, which you all just looked up. Whoops. What is the integral of tangent?
Is it tangent squared?
Oh, it is tangent squared. So maybe we don't want to change it, do you? I don't think we want to, do we? Maybe we just want to leave it like it was, because it's easier to work with. What's the antiderivative of secant squared? That's actually tangent, isn't it? The antiderivative of secant squared is actually tangent, so changing it in this particular case wouldn't have been very helpful. What's the antiderivative of 1? It is x. And there's a plus c here going on somewhere, right? All right, so we're going to clean this up just a touch, and then we're going to figure out what c is. So this is actually cosine of x times tangent, but tangent is sine over cosine, right? And then I have x cosine of x plus c cosine of x. You might want to make that c really big and capital or something so that you don't think you just put 2 c's on a cosine or something. And then the first piece, of course, simplifies to sine, right? So we have sine x plus x cosine x plus c cosine of x. And how are we going to figure out what c is? Yeah, there was a piece of information back at the beginning that said y of 0 equals 1. So how am I going to use that? What is that telling me to do?
Plug in the points.
Right, so where will 0 go? For all the x's, and 1 will go for y. So this is 1 equals sine of 0 plus 0 cosine of 0 plus c cosine of 0. All right, so I've got 1 on the left. What is sine of 0? 0. The second piece actually says 0 times cosine of 0, so that's going to also be 0. Plus c, and then what is the cosine of 0? That's actually 1. What's c? It's 1. C is 1. So our answer to our problem let me just write it right here, is actually y equals sine x plus x cosine x plus cosine x. You might see your book factor that cosine of x out and write it as x plus 1 times cosine of x. I don't care that you do, but just be aware that they might do this instead. Does everybody understand that step and why it would be the same? All right.